Well, hello all. I am really chuffed, bigly chuffed. I guess I can't say I'm proud of the way this particular project turned out. It's been one of my favorite projects. And let me show you what it does. I've built a little remote here. And when I point it at this receiver, it switches on a row of LEDs. And when I press it again, it goes off. So what have I done? I've built an infrared remote. I've built an infrared receiver. There's a relay. So when I switch it on, the signal from this remote is picked up by the Pi Pico, which is turned on. It's first picked up by the TSOP, which turns on the Pi Pico. The Pi Pico then turns on a transistor. The transistor turns on the relay turns on the bank of LEDs. So that's the order in which everything occurs. And each of those steps was a little process in itself. So what I'm also pretty proud of, or bigly chuffed about, is the fact that I had to build my own infrared protocol. I wasn't using any protocol, so no other remote will turn on or off this receiver. So, and it works over many meters, so I can lie in bed and have it turned on and off. And this can all, at the moment, it's been attached to a 12-volt power supply through the mains. And the 12 volts is powering the LED strip, but then a 5-volt power bank through a USB port powers the Pico, which powers all the TSOP, and there's also a relay and a transistor 2N222 transistor to turn on the relay. So what's so nice about it is it all seems to work pretty nicely. The TSOP's actually facing the wrong direction, but if you just turn this around, and it all seems to work really well. So I'm going to show you in quite a lot of detail how this is made with a Pic12F1501. So all that this does is when I press this button, this little bell switch, all that it does is it broadcasts a 38 kilohertz continuous signal. So that is all that this Pic12F1501 is doing. It's just, while I hold down the button, it's transmitting a continuous, unbroken 38 kilohertz vibration. The TSOP is designed to be susceptible to that vibration, and what I programmed the PIC to do is to count to over 400 times. Now, most remotes will not do it continuously for anything longer than 400. So as long as it's counting 400 periods, and each period is 26 microseconds. If you take the frequencies 38 kilohertz each period, each single wave, one on and one off, takes 26 microseconds, or 13 microseconds on, 13 microseconds off. So all that the Pi Pico is doing is counting, and when it gets up to 400, it knows that it must toggle the light on, and if it's on, it must toggle it off. So the programming is really, really simple, and I'm going to put the circuits on, and I'm going to put the program for the PIC and the program for the Pi Pico, and I'm going to give the circuit diagrams. I'm going to give you everything I think that you will need to actually build the circuit, and in the description I will give the actual programs. This is programmed MicroPython Thonny. This is MPLAB, and it's programmed in C. That is programmed in MicroPython. So I'm going to give you the programs, I'm going to give you the circuits, and I'm going to show you how I went about this is the final product where I've put it together. Isn't it beautiful in its ugliness? There's the 4 battery on a battery bank, and there's the little remote. Isn't that the ugliest little remote? But I love it in all its ugliness. So let's show you how we did it. So here is our Pi Pico. Here is the lead that comes in. So this is a TSOP. It's a little infrared receiver that is tuned to 38 kilohertz, and it picks up signals, and what it actually does is it goes low when it picks up a 38 kilohertz signal. So if you are looking at your Pi Pico, here is pin 0 all the way up to, there's 40 pins, I believe. So if we start over here, 1, 2, the 3rd pin is ground. The 5th pin is 3.5 or 3.3 volts. So in this particular TSOP, and every TSOP is different, the middle pin is the ground. It goes to the 3rd pin from the end. The end pin here is the positive pin, and I've attached this to the 3.3 volts. And the 3rd pin is the output from the TSOP. So this goes to pin 0. So our program is going to look on pin 0 to see whether there's a signal or not. Then on pin 1, which is on the exact opposite side, so this is 0, 1, it goes up to pin number, I think it's 17 there, or 15, and then 16, 17, yeah, 15 there. So on pin number 1, so 0 picks up, is an in pin for the TSOP. Pin number 1 is an out pin that goes to the base of this is the little transistor. This here is a relay. And I don't think I'm just trying to think whether how well you'd be able to see this. But anyway, let's just focus on this. Is a 2N222 transistor, and it's got a flat part, it's got a round part, and the middle leg is the base. So the base is biased by pin 1 of your Pi Pico. And then here we've got a 5-volt battery bank, which goes to the one side of the relay. So now this is what turns on the relay. So 5 volt comes in here, it comes out here. This is the collector. Here's the base, here's the emitter of the 2N222 transistor. So the current is flowing like this. It comes to here. When this is biased positive, the current flows. It flows out of the emitter, and then a current will be able to flow, and then it goes to ground. So, and there's a common ground for everything's got to be grounded in common. So here's the current. It flows through the collector when this is biased positive, out through the emitter and to ground. So there's a current that switches on the relay. Once the relay is switched on, this is supplied with 12 volts, the common, and it goes through. So here's the supply of 12 volts. It goes through here. This is a switch, and it goes and switches on the LED strip, and then it goes to the 0 volt. So there's the 12 volt plus 12. There's the minus, there's the 0 volt, and here in between is our LED strip. So this is attached to the common, the 12 volts, and this is to the normally off. So that I use normally off. So there's the normally on part of the relay. So that means normally this light is off, but when a current flows through, this will switch the bank on. So this has got to be powered before the LED strip will come on. So that is basically the electronics of how this all works. is on the Pi Pico a thing called Thonny is the program driving this, and our program is called main.py, and it is saved onto the Pi Pico. We first import a pin. You've got to import pins if you want to send things in or out of the Pi Pico. We have to, if we're going to use timing, we use import sleep. That's for the timing. Then I make the LED is pin number 25. There's a little LED that lights up that's built into the Pi Pico. LED 1 is going to be the out, and that is going to be the pin 1 that drives the transistor, which drives the relay. Then there's a pin 0, which is the pin in that comes from the TSOP, pin 0, and that is the input pin from the TSOP. Count is 0, LED value is 0, LED 1 value is 0, while true. Now we start our endless loop here. Logic state equals push button value. Okay, so now we look at the logic state. We're looking to see if the button's pushed or not. Logic state starts at false. And we start counting, so it's not being pushed. So if it's false, it's not being pushed, or actually, false means it's 0. The TSOP pulls it down to 0. So false means it is detecting a circuit. And if it detects a circuit, it starts counting how many cycles, how many periods of this get, and we must count up to 400, or actually 500 it says here, if count is greater than 500. So if it's false, meaning the TSOP is registering a 38 kilohertz signal, start counting. Otherwise, make count 0. So just keep it 0 if there's no TSOP value. But the moment that we press our infrared remote, it's going to send out a signal, and then the false is activated. So false is good. That's what's going to be starting to be counted. So there's an if and an else. Then, after it's performed that, if the count is greater than 500, LED toggle and LED 1 toggle. So it toggles the light, the inbuilt LED on the Pi Pico, and it also toggles our LED 1 is going to drive our bank of LEDs. Then we reset the count to 0 and we sleep 1 second. We do the sleep for 1 second to make sure that the light, the LED strip doesn't toggle on, off, on, off, on, off. There's a 1 second delay for allowing the person to remove their finger from the button. And that is all that there is to this Thonny MicroPython Pi Pico program. Program that is written for the Pic12F1501, and this is done on MPLAB, and it's in C. So we define the crystal frequency to be that. We include that in the library. We set all those configurations on the Pic12F1501. Clock out, watchdog timer, brownout detection, mclear, and so on. I just copied these from some other program. Now we come to, here is the main program. We've got to set the tri-state A to be that. Ancel A is 0, all pins are digital. We don't use analog. The tri-state is, we're using those particular pins of the Pic12F1501, so those are going to be used. Again, I think I probably copied this from some program. So let's just go to the main loop. So this is here your main loop. So we've set the clock to 16 megahertz, and we're using the internal clock. That's what these do. As I say, I copied all of this. To tell the truth, I don't really understand it too much. I vaguely understand it, probably enough to just work with it. But here is the actual bit of programming that's interesting. So I will post this program in the description,
and you can just copy it. So so we start an infinite loop. So while this is switched on, it makes all the pins on the Pic12F1501 to be on. All LEDs are on. We delay for 30 microseconds. Then all the LEDs are off, and we delay for 13 microseconds. And this just keeps on doing that. So as long as this program is switched on, there's only 2 lines that matter, or 4 lines that actually matter. All of this is just setting it up. And working on a Pic12F1501 or any PIC using MPLAB, it's for geniuses and clever people, which I'm not. But I know enough to monkey see, monkey do, copy it. So I can copy it and work with it and modify it as I need it. So I wrote this little bit here, which works perfectly. And this is the whole infrared protocol. We're just sending a continuous beam of 38. This creates, because it's on for 13 microseconds and off for 13 microseconds, that creates a 38 kilohertz signal. I'm not even using, I could have used, it has the ability to do, what is that called, where it can send out frequency. But anyway, I'm creating the frequency myself. Sorry, I've forgotten it. Pulse width modulation, or yeah, it can do it. It can actually create a signal, but that's complicated programming. So I just chose the simple route of creating my own signal. And that's all that this program is doing. It's sending, and this creates a 38 kilohertz infrared signal through, I send it through an infrared LED that's got a 47 ohm resistor. And I will show you the circuit for that. So there we go. This is the program that is used by MPLAB to program just the infrared remote.
So here is our Pic12F1501. It's only got 8 pins. There you see 1, 2, 3, 4, 5, 6, 7, 8. Number 8 is attached to 0 volts, in other words the ground or whatever. Then pin number 1, or if you want to number them 0, but anyway, this first pin here goes to the 5 volts, so 5 volts, 0 volts. Then we've got from pin number 2 here, the second pin, we go through, I used a 47 ohm resistor here. Here's an infrared LED, and when this pin number 1, well, it's the second one from the end, is turned on, then this LED is turned on. So it's a very simple circuit. It's got a power supply, 5 volts. There's only 3 pins used. The VSS, which is 0 volts, the VDD, which is 5 volts, and this pin, which is the output for the infrared. And when that is turned on, it sends a signal through the resistor, through the infrared LED, and then there's your completed circuit. As I showed, this may be a little easier to see. This is the same as the previous diagram. The only difference is instead of using pin number 13, I decided to attach this to pin number 1. There, this is 0 and 1. But otherwise, there's the circuit again. That 3.3 volts goes to that pin of the TSOP. The middle pin of the TSOP goes to ground, and that pin goes to, I made it go to pin number, I think it was 0. Let's just see. We made it go to pin number 0, yeah, from the TSOP. So this is perhaps a slightly easier to see diagram of what's happening. Here is a close-up look at all our components. So there's the TSOP, there's 3.3 volts, there's the ground, there's the output from the TSOP. It goes to pin number 1. So that's the input. Then there's an output that goes to the back of this. Now on the back of this, we've got our relay. So there's the relay, there is the transistor, and there is the protective diode for the relay.